In this video, we are going to talk about the unit circle and how we build it. So from geometry, we learned about 30, 60, 90 triangles, and we have reviewed those this year. So the ratio of a 30, 60, 90 triangle is side, two side, and side root 3. Now, let's say that our hypotenuse, or our two side, is equal to 1. That means side would be equal to 1/2, and our side root 3 would be equal to root 3 over 2. Our triangle would look something like this. Now let's place this triangle on a circle, like we've been talking about with rotations of angles. So then, if I have a triangle, I know that my horizontal distance of a unit circle is 1. So this point would be 1, 0. This point would be 0, 1. This point would be -1, 0. And this bottom point would be 0, -1, assuming that the origin is in the middle. So now if I have this triangle on this circle, I can see that my horizontal distance is root 3 over 2, and my vertical distance is 1/2. Therefore, the point on the circle is going to be root 3 over 2, 1/2 for this 30-degree reference angle. Now, I could also take that same triangle and put it in quadrant 2. And it'll have the same ratios. The only difference in quadrant 2 is that while my y is still positive, my x is going to be negative. Now I can do the same thing in quadrant 3, but in quadrant 3, both x and y are negative. And I can do the same thing in quadrant 4, where now my x is positive, but my y is still negative. Now, we use this 30-degree reference angle to find these 4 angles. So if I go 30 degrees for this 30-degree reference angle in quadrant 2, this angle is really 30 degrees shy of 180, because we know that over here is 180. So it's going to be 150 degrees. I put the same triangle in quadrant 3, that's 30 degrees more than 180, so I know that that's 210. And then I'm going to put the same triangle in quadrant 3, which is 30 degrees shy of 360, so it's going to be 330. And so those are our 4 triangles, our 4 30-degree reference angles on our unit circle. Now, we can do the same thing with the same triangle. I'm just going to have 60 degrees be the main reference angle. So we have the same ratios we talked about with the 30-degree triangle. So I have 1/2 root 3 over 2 and 1 as my hypotenuse or radius. So let's take and put this triangle on the circle. So just like before, I have my quadrantals 1, 0, 0, 1, -1, 0, and 0, -1. Now I can take this triangle, but now the point up here is going to be 1/2, root 3 over 2. So same numbers, just reverse, because now 60 degrees is my reference angle. So I'm going to take the same triangle and put it in quadrant 2, and we'll have the same point just with a negative x value. Same with quadrant 3, same point, but 2 negative values. And then quadrant 4, same thing, but a positive x value and a negative y value. Now we've gone over about, 4 points on the quadrants and 4 points for each triangle, so we're at 12 points that are on our unit circle. Now again, with that 60-degree reference angle, that'll give us more angles. So 60 degrees shy of 180 is 120. 6 in quadrant 3, 60 degrees more than 180 is 240. And 60 degrees shy of 360 is going to be 300. Those are some main degrees on our unit circle. Now we can do the same thing with our 45, 45, 90 triangle, and this is going to fall in between 30 and 60. So our ratio for a 45, 45, 90 is side, side, side root 2. So again, let's say that our hypotenuse is equal to 1. So that means side root 2 is equal to 1. So that means our side is equal to 1 over root 2, but we don't like to leave our answers like that, so we need to rationalize it. And when we rationalize it, we're going to get root 2 over 2. So that's going to make our triangle look like this: root 2 over 2, root 2 over 2 with a hypotenuse of 1. So let's place this on our triangle now. So now this means that our x value is root 2 over 2 and our y value is root 2 over 2 for any 45-degree reference angle. And we're going to have 4 of those. So we have the original 45. Then we're going to have one in quadrant 2, which is 45 degrees over in quadrant 2. And again, a negative x and a positive y. Quadrant 3 is negative x, negative y, and quadrant 4, which is positive x, negative y. Now, if I'm going 45 degrees shy of 180, that's going to be 135 degrees. Then in quadrant 3, I'm going to go 45 degrees past 180, so that's going to be 225. And then in quadrant 4, I'm going to have 45 degrees shy of 360, so that's going to be 315. So that's another set of our angles. So now let's put this all together. So I'm going to take my 30-degree triangle with my ratio. I'm going to put my angle, my coordinates in. So for anything that's a 30-degree reference angles is going to have the coordinate √3/2, 1/2, changing positives or negatives depending on the quadrant. I'm going to do the same thing with a 60-degree reference angle. But now this coordinate is 1/2, √3/2. And that'll be the same for all 60-degree reference angles. So in quadrant 1, in quadrant 2, in quadrant 3, and in quadrant 4, just changing positives and negatives depending on what quadrant we're in. And we can do the same thing with our 45, 45, 90 triangle. So we have the same ratio we just talked about, √2/2, √2/2. Same with quadrant 2, just a negative x. Quadrant 3 is a double negative, and quadrant 4 is a positive x, but a negative y. Okay, so those are all the coordinates that are on our unit circle, including our quadrantal coordinates. So we will need to know these, we will memorize these, and we will be memorizing the angles, and we're going to talk about that next. So with that in mind, we have our quadrantal angles, which we've already talked about, 0, 90, 180, 270, 360. Now, if we add in our 30-degree reference angle, we have 30, 150, 210, and 330. Then if we add in our 60-degree reference angle, we have 60, 120, 240, and 300. Then in between those, we're going to add in our 45-degree reference angle, so that's 45, 135, and 315. Then if we add in our coordinates, we can see that all of the 30-degree reference angles have the same coordinate, just changing positive or negative. Same with the 60, and same with the 45. So now this is a complete unit circle with all degrees and all coordinates, but we also know that not only are there degrees when it comes to trigonometry, but there are also radians. So we're going to talk about that next. But to remember these, keep in mind that we are going to walk around by 30 degrees. So for all the 30 and 60, 90 triangles, it goes 30, 30 plus 30 is 60, plus 30 is 90, plus 30 is 120, plus 30 is 150, plus 30 is 180, plus 30 is 210, plus 30 is 240, plus 30 is 270, plus 30 is 300, 330, and then back to 360. So we can just walk around and add 30 each time, and that'll help us fill in all of those angles. Now for 45, it's going to be similar. So we're going to start off with 45 degrees. 0 plus 45 is 45, plus 45 is 90, plus 45 is 135, plus 45 is 180, plus 45 is 225, plus 45 is 270, plus 45 is 315, and then plus 45 is 360. So that is how we're going to fill in our angles when it comes to degrees. You can do the same thing with 60, but I always just use the 30-degree walk-around method. All right, so now we're going to talk about radians. So for our 30-degree reference angle, this is actually pi over 6. They're not on radians yet. I apologize. They're just showing the whole unit circle. So now this is the whole circle with all the coordinates and all the degrees. All right, so now we're going to talk about radians. So we talked about that from 0 to 2 pi. 2 pi is all the way around the circle. So halfway around the circle is pi. Half of half is pi over 2. And then we have 3 pi over 2. So we've already talked about these quadrantal angles. Now we're going to fill in the in-between. If I divide the circle into quarters, this is my 45-degree reference angle. But that's a quarter, so half of a half is a quarter. And then the next one is 2 quarters, which we reduce to 1/2, then 3 quarters, then 4 quarters would be pi, then 5 quarters, then 6 quarters would be 3 pi over 2, but it reduces, then 7/4 is the last one. So that is how we're going to fill in our 45. Just like we added 45 each time, we're going to add 1/4 each time. So everything that's a 45-degree reference angle that's in the very middle is going to have a denominator of 4. Now for the 30 and 60, these are also going to go together. We're going to divide the circle into 6 parts. So we're going to start with pi over 6. So that's 1/6. 1/6 plus 1/6 is 2/6. So 2/6 is going to reduce to, Then we're going to go 3/6, then 4, then 5/6, then pi is 6/6. Then we have 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6. Now, if you notice, if you look at all the ones that are in green or in black, those all can be reduced. So those all are going to be reduced. But we can use the 6th rule to count them out and then reduce them after. So pi over 6 will reduce to pi over 3. 2 pi over 6 will reduce to pi over 3. 3 pi over 6 will reduce to pi over 2. 4 pi over 6 will reduce to 2 pi over 3. This one doesn't reduce. This one obviously reduces to pi. 7 pi over 6 does not reduce. 8 pi over 6 will reduce to 4 pi over 3. 9 pi over 6, we know that this spot is actually 3 pi over 2, so it will reduce. 10 pi over 6 will reduce to 5 pi over 3. 11 pi over 6 does not reduce. 12 pi over 6 will reduce to 2 pi. So these are our radians for our 30, 60, 90 triangles. And so again, we're adding a 6th every time. So let's put it all together now. So if we do our quarters first, 1/4, 3/4, 5/4, 7/4, then 6. So 1/6. Then 2/6 is 1/3, 3/6, then 4/6 is 2/3, 5/6, 6/6 is pi, 7/6, 8/6 is 4 pi over 3, 9/6 is 3 pi over 2, 10/6 is 5 pi over 3, and then 11/6, and then 12/6 would be 2 pi. So we put this all together now. We can show you that if you were to multiply these and convert, so I multiply by 180 over pi, it converts to 30 degrees, which we already know. So this is using our conversion formula to show that the degrees and radians are actually the same, just a different unit of measure. So you do not need to fill this all in, but we will fill it all in with the degrees and radians very soon. And so then we're going to add in our coordinates that are the same as the degrees. Feel free to pause the video now to fill in these coordinates. Then we're going to put it all together. So there's all my degrees. There's all my radians. And so now we're going to fill this in on our complete unit circle. And then we have all of our coordinates. So this is a completed unit circle with all coordinates, all degrees, and all radians. We are going to practice filling this